Hey Education Boxer, welcome back to another video. In this video, we'll be going over limits. So this video will mainly be an introduction to limits, since limits are quite complicated, and I'll be making a separate video about evaluating limits and the formal definition of limits and stuff like that. So this is my second video in my series Learn Calculus, and as I mentioned in my first video, limits are an extremely important part of calculus. They help us understand derivatives and integrals and all stuff like that. So what is a limit? So let's take a situation. So sometimes we can work out things directly, but we can see what it should be as we get closer and closer. So let's say we have a quick equation, x squared minus 1 over x minus 1. Now let's try working it out for x is equal to 1. 1 squared minus 1 over 1 minus 1 is equal to 1 minus 1 over 1 minus 1, which is equal to 0 divided by 0. Now 0 divided by 0 is a challenge. We don't really know the value of 0 divided by 0. It is indeterminate. So we need another way of answering this type of a problem. So instead of working out what x is equal to 1, we can try approaching it closer and closer to the value of 1. So let's try x is 0.5, and after that we get 1.5 if we input 0.5 as x. And then we can try 0.9, and then our output will be 1.9. And then we can try 0.99, and we'll get 1.99. And we can continue going, getting closer and closer to 1. And what we can notice here is that as x gets closer to 1, then x squared minus 1 over x minus 1 gets close to 2. So we're faced with a situation now. When x is equal to 1, we don't know the answer, but we can see that it is going to be 2. So we want to give the answer 2, but we can't. So we say what is exactly going on by using the word limit. So the limit of x squared minus 1 over x minus 1 as x approaches 1 is equal to 0. So in symbols, it is written like this. The lim as x with an arrow, meaning approaching 1, and then the expression x squared minus 1 over x minus 1 is equal to 2. And another way to check if you're correct is by checking it from the other side. So we started from 0.5 approaching 1, but now we can start from 1.5 approaching 1 as the values get smaller and closer towards 1. So if we try substituting the values for 1.5 in x, we get 2.5. If we substitute 1.1, we get 2.1. If we substitute 1.01, we get 2.01. And we can continue doing this again and again, and we can see that it's also heading for 2, which means that we are correct. Okay, so now let's take another interesting concept, which is infinity. So infinity isn't a number, it is really an idea. So we know we can't reach infinity, but we can still try to work out the value of functions that have infinity in them. So let's take an interesting example. So what is the value of 1 over infinity? Well, the answer is that we don't really know. It is undefined. The reason is because infinity, as I mentioned previously, is not really a number. It's an idea. So the answer to 1 over infinity is known to be undefined. So now what do we do from here? Well, knowing that limits exist, we can try approaching it. So instead of trying to work it out for infinity, because we can get an answer that works, let's try larger and larger values of x. So let's say we have 1 over x. So if we try 1, we get 1, of course. 1 over 1 is 1. If we try 2, we get 0.5. If we try 4, we get 0.25. If we try 100, we get 0.01. If we try 10,000, we get 0.0001. And we can see as x gets larger, 1 over x heads towards 0. So we are again faced with a situation. We can't say what happens when x gets to infinity, but we can see that 1 over x is going towards 0. So again, we want to give the answer 0, but we can't. So we use the word limit. So the limit of 1 over x as x approaches infinity is 0. And we write it again like this in mathematical terms. Limit with lim as x approaches infinity, 1 over x is equal to 0. So in other words, as x approaches infinity, then 1 over x approaches 0. So whenever you see the word limit, just think of the word approaching. So now in my next video, I'll be going over limits to infinity in more depth and evaluating limits. Thanks for watching.